Hey everybody, Mr. Piercy here, and what I'm going to be talking about in this video is going to be properties of altitudes and inside of a triangle and the point of concurrency that they create. So what I'm going to use is I'm going to use my compass and my straight edge to form some altitudes and see what we recognize about them. Now, one of the things that I regularly see as a misconception by my geometry students in class is the idea of what a height of a figure is. The misconception that I see by my students in class almost without fail every year is that students believe altitude, otherwise known as height, must go up and down. And that's simply not the case. The definition of the altitude says it must go for the shortest distance from a vertex to the side across from it, which means it must be perpendicular. So this segment that I've just constructed, I'll call this point D. Segment BD is an altitude of the triangle, even though it does not necessarily go up and down. And since segment BD is considered an altitude, segment AC would be considered its base. So let me go ahead and construct the other two altitudes here real quick. And all I'm doing is using the perpendicular construction from a point to draw the altitude. And I can see here on this segment AB, I'm going to have to extend the side out some so I can actually do the construction properly. So let's see. There's something there and something there. Okay. And now we can get this altitude in. So there's a right angle. We'll call that point E. And finally, the altitude from A. And we might extend side here out just a little bit also, so I can perform the construction well. And so about here and here. Oh, let me come back in here. Alright, so now we can see the three altitudes inside of this particular triangle, and we'll call that point F. Now what you recognize, as you've probably seen with other segments of triangles, that the altitudes do have a point of concurrency between them. Here I'm going to call this point O, and I'm calling it point O because O is the abbreviation for the name. The point of concurrency of the altitudes is known as the orthocenter of the triangle. Now, that doesn't necessarily have much bearing on anything that we'll see as far as the triangle and that point of concurrency. There's no special relationship like there is with an incenter, a circumcenter, or a centroid. For our purposes, all we need to understand is that the orthocenter simply is the point of concurrency formed by the altitudes of a triangle. Now, there's one thing I want to there's one extra thing I want to make sure everybody understands about the point of concurrency itself. So this is what it would look like for an acute triangle, pretty much all the time. Somewhere the orthocenter should be inside of the triangle. Now for a right triangle, because the definition of an altitude says it must go from a vertex to the side across from it at a right angle, then that means that the two legs that form the right angle of the triangle itself are already altitudes. So the only altitude I needed to construct was from point B to the hypotenuse of the triangle, and the 3 points touch at the right angle, or the 3 altitudes touch at the right angle. So in that case, point B of my triangle is the orthocenter here. So we've gone from an acute triangle where the orthocenter is inside of the triangle to a right triangle where the orthocenter is actually on the triangle itself. So what would it look like for an obtuse triangle? Well, I can tell you from experience in class, the obtuse triangle is the one that's going to cause the most trouble with students as far as seeing where the altitudes are. So here we have an obtuse triangle, ABC. And what we're looking at here is from the acute angles, we can see that the altitudes of the triangles actually have to be outside of the triangle itself. They can't actually be inside. The only altitude that will be inside of the triangle itself will be this one here from the obtuse angle. So what I had to do when I did my construction is I had to extend the sides out so I could see where that perpendicular segment would be. So here I have this line extended out, so there's my red line from point C. Now, in order to make sure that we can see where the orthocenter is located, I had to extend this blue line out. So here, outside of the triangle, is where the orthocenter is actually going to be located. And that's going to be the case for every obtuse triangle. So we've gone from having the orthocenter inside of the triangle with an acute triangle, on the triangle with a right triangle, and now outside of the triangle for obtuse ones. Now that's pretty much it for what I wanted you guys to understand for altitudes and orthocenters, how the altitudes are formed, making sure, especially with the obtuse angles, we're understanding that two of the altitudes are going to be outside of the triangle, and seeing that where the orthocenter is going to be located based on the type of triangle it is.